Today we're going to go through replacing the rubber repair parts in a pilot-controlled pressure regulator. And we're using a clay valve model 9001 pressure regulator here for our demonstration for today. They're called a pilot-actuated pressure regulator because the pilot is what actually regulates the main valve versus the direct-acting pressure regulators, which we use in smaller applications, residential and applications like that. In the larger applications, we need more control, and that's where the pilot-controlled pressure regulators are usually used in the applications, larger sizes. Anyway, replacing the parts, there's going to be two basic parts we're going to look at that we're going to be rebuilding. One is the main body itself, which has a diaphragm and a regulator disc. And this is the main part that opens and closes in control with water through the piping system. There's an inlet side and an outlet side. And the pressure is actually controlled by this little unit here. And this happens, the clay valve unit happens to be called the CRD. But this is the pilot that actually controls the workings of the regulator. In other words, inlet pressure comes in on this side out here. This maintains a constant pressure on the downside regardless of what the pressure on the inlet is. Usually lower pressure is what we're trying to maintain. With the pilot-controlled regulator, there's literally millions of applications that you can make up by changing different bypasses and different tubings. By a simple tubing on the top, you can add a check feature. By putting other control valves on there, you can have pressure sustaining and volume controls and lots of other options that are available. But we're just talking about a basic pressure regulator today. Again, as I said, the clay valve 9001. So let's take a look and see what we're going to have to rebuild. First of all, when we look at this, we have to identify what it is. I'm telling you this is a clay valve 9001. And there is usually a tag on the valve right here, which will have the model number, serial number, and more importantly, the specific recipe of what is in this assembly. As I said, by adding different controls, this particular valve can do a myriad number of different functions. So the first thing you have to know is what functions it's designed to do. We're just talking about a basic pressure regulator today. So back to the main part, body, control valve. Let's talk about the body first. What we see here is a 3-inch flanged body. The body comes either flanged or some of them are actually threaded. They make a threaded size up to 3-inch. They make the flange sizes from 2.5 all the way up to 48-inch, at least clay valve does. And the body, as you can see, has, well, clay valve calls it their blue, but that's the coloring of the epoxy on it. The body comes in 3 basic materials. It can either be ductile iron, which is their standard material, which you see here. It can be cast steel, which is usually used for high pressures. Or it can be a bronze body, which is used more in marine applications or places where outside corrosion it can be an issue, or inside corrosion, scale can be an issue. So those are the 3 different bodies that you may have. On the ductile iron, this one happens to be fused epoxy, which is an option. They can come in raw ductile iron, or like this one can have a fused epoxy to minimize rust inside the unit. So, to rebuild this, the first thing we have to do is disconnect our pilot system. This happens to be a stainless steel piping system. The normal one would be a bronze 3/8 tubing. So I'm going to remove this piece of tubing now, which isolates the pilot system from the main valve, allowing me to disassemble it. Now, up to 6-inch, this cover, well, this is a 3-inch. Up to 6 inches cover is relatively light and can be easily pulled up. But on the larger sizes, 8-inch and above, they actually have little eyelets on the top of the cover so that you can put eye bolts in here. And what that's necessary is on the 8-inch all the way up to 48-inch, you cannot just pick the cover straight up. And it has the ability to put eye bolts in here so it can be lifted up with a crane or some kind of block and tackle system. So depending on the size, 6-inch and under, usually the cover can be pulled up by hand. 8-inch and above, you may need assistance, and they do put jackings, eyelets in the top of the cover so that eye bolts can be placed in there. Now, once we go to take this apart, there are bolts along the outside. Obviously today we're looking at a cutaway so you can kind of see what it looks like as we take it apart. First thing we're going to do is remove our body bolts. The bolts will come off. Up to 6-inch, you're going to see bolts like this, where it's a bolt mechanism where the thread is in the body. 8-inch and above, you're actually going to have a stud protruding from the top, and there will be a nut on the top. So depending, if it's an 8-inch above, it'll be stud and nut. If it's 6-inch and below, it'll actually be a bolt. If you have the stud and nut type and you take the nut off and it comes apart, that's okay because, I mean, the stud comes out. It's okay because putting it back in, it'll have that same length to tighten down the cover. Once you remove the bolts, there is a small spring in here, but then it has very, very little tension on it, or little load on it. So unfortunately, it's not going to lift the cover up like this in most applications. Usually the diaphragm is bonded to the body, and it has to have a way of releasing that. If you'll notice, there is a slot on the bottom of the cover right here, between that and the body. And it's angled at such a point that you can get a cold chisel, something in here that you can hammer upwards to release the tension of the diaphragm on there. So small little hammering is usually needed for that purpose. Once I've loosened the cover, I want to pull it up very carefully because you'll notice there's spring tension here, but you'll also notice inside that spring there's a stem, which I want to be very careful of. Because as I pull the cover up, you'll notice that there is a bushing screwed in the top of the cover. That's a very important part that correlates to the stem, corresponds with the stem here that it travels in and out of. So as I pull it up, I want to be very, very careful that I don't nick it, scar it, the stem as I pull the cover up off the body. Once I've got the cover off, my spring will come out next. The stem assembly is now what will come out. This being a 3-inch unit, this is relatively easy to pull out like this. Again, on a 3-inch body, that it's very easy to pull it out because it weighs a relatively small amount. But on the top of the stem, you'll notice that they've installed a small threaded here on, depending on the size. On the 3-inch, it happens to be a 1/4 inch by a fine thread. And this allows you to place this in to lift it. So if this was a larger size, meaning an 8, 10, or 12, I couldn't just pull that diaphragm out by hand, but I could put something like this in, which allows me to lift it out with the crane or jacking system to get the disc holder and diaphragm assembly out in one piece. After I've removed that, then I've got the body left, and inside the body will be my seat. The seat is inside the body here, sealed by an O-ring, as you can see here on the bottom. Actually, the very earliest ages of these, they were just a pipe thread that's sealed in, but the majority that you're going to run across do have the O-ring seal right there. The seat comes in stainless steel or bronze, depending which trim you have on it. The seat can be removed on the 1/2 inch through 1 inch. The socket actually fits a hex size to remove that. 1 1/4 through 6, you need a special tool that goes in there and actually grabs those 3 legs right there and allows you to unscrew that seat. There you can see the O-ring on the back side. And above 8 inch, the seat is actually held in by screws. And by removing the screws, then the seat can be removed. So these are the 3 main parts of the main high-troll body we're going to look at. Our cover, which has the bearing, our spring, which sits right on that bearing with the stem, our body, which holds our seat, and our stem assembly like this. Pilot system, we're going to hold off on that for a minute. Let's go ahead and take a look at our diaphragm assemblies and see what it takes to rebuild them. I have 3 different versions here for you to see. The one you see here is a stainless steel trim, which is not a standard. The standard is usually a ductile iron like this one that has no coatings on it. In other words, raw ductile iron. One of the issues with the raw iron not coated is that it can be susceptible to rust, causing a lot of rust growth, which can cause problems as it moves inside the body. They also make an epoxy-coated version, which is the one that shows in most applications. And this way that the iron doesn't rust because it has a fused epoxy coating on it. And of course the stainless steel trim one we see here. So those are the 3 different versions that you may run across in the field. So we'll take the cutaway one apart to see what it looks like. When you do rebuild it, you're going to need a factory rubber repair kit, which contains a diaphragm, a disc, which is on the bottom, and these very important spacer washers, which we're going to talk about here in just a minute. So taking our stem assembly here, first thing we have to do is inspect the stem. What we want to make sure is that the stem here on the top portion and on the bottom portion is perfectly smooth. When I say perfectly smooth, it should be like glass. You should be able to feel it. It's going to be stainless steel. In other words, regardless of the trim, the stem itself is stainless steel. It's a hardened material so that as it slides up and down, it doesn't have any issues with galling, or minimal issues with galling or scarring. As I'm looking at it, the first thing I want to see is what's wrong with it. In other words, as I go to repair anything, I want to fix what is wrong. If you were having problems where the pressure kept going up, sometimes the disc doesn't seal on the seat. So I'm going to inspect the disc to see if that was my issue or if the seat was damaged. Sometimes if you have the ductile iron versions that are raw material, there's a large amount of rust that grows in the body and the stem can't move after a while. But anyway, we'll take it a piece at a time. Let's start with our stem assembly. Now on the back side of this nut, you can see that some of those threads are protruding through the top where that nut is. In other words, the nut comes down certain distances on this, and depending on the size of the stem, fewer or more threads may be exposed. The first thing you want to do is clean these threads before you try to loosen this nut. The reason you want to loosen those threads is because if you leave that full of scale and as you go to loosen the nut, that extra torque can cause issues where it can cause issues of scarring the stem. What you want to do to rebuild this on the small sizes, meaning 8" and below, there's no real easy way to grab it. You'll notice that it's a round stem here on the bottom and a round stem on the top. So what you want to have is something soft to grab it, a soft vise with a brass jaw or something like that that won't scar or nick that stem is critical. On 8" and above, there's actually a wrench flat down below. You'll see there's a wrench flat here on the 3", but unfortunately where it's located, you can't get a wrench on it very easily. It is possible to, like this, hold it there as you're trying to loosen that. But it's obviously easier with a vise because this nut has to be very tight. It has to be tight because you're facilitating a water seal across this diaphragm, these little red spacer washer you see here, and this stem. In other words, there's one nut that tightens this whole stem assembly up. And if this nut is loose, water will leak right past it, and your pressure regulator will not work. So what we want to do is get something good to hold that, proper size end wrench on here. Now, taking this nut apart, first thought is, okay, how strong am I? Can I go ahead and remove this? It's not a matter of strength. When you're dealing with the metals on this material, you have dissimilar metals between the stainless steel and the ductile iron, whether it's fused epoxy or not. So what's needed is a shocking action. In other words, you want to put the proper size wrench and you want to get a hammer and you want to actually use a hitting action to loosen that nut. Because it's not a matter of strength as it is the shock that removes that metal, the two different similar metals apart. So once you get on there, get a hammer, hit it hard, make sure it's properly held so you don't scar that stem. If you scar that stem on the top or the bottom, you're going to have to replace it because any marks on that stem will restrict the movement of that stem assembly. Diaphragm retainer comes off first. Our diaphragm next. Our disc holder here. These spacer washers that I told you about. And our disc retainer and our stem. So those are the parts of our stem assembly. Replacing the disc is just a matter of removing it like that, putting the new disc in place, having my diaphragm ready. Want to make sure I line up my bolt holes so I know that the diaphragm is going the right direction, making sure it lines up before I put it back together. Now I want to reassemble this. Mention these spacer washers as a very critical part because what these spacer washers do is take up the differences in tolerances between the disc retainer and the disc holder. In other words, these two parts come together like this, and this holds that disc into the stem. Now one of the problems is that the differences between these 2 points right there, the disc holder and the disc retainer, as you can see there's quite a little gap right there. And the function of this retainer is to take up that gap. Because if all I did was tighten that nut and squeeze down on this, I would bulge this disc out of that disc holder. Instead of it being a perfectly flat disc, by over tightening it, the disc bulges out of that holder. And now instead of it being a flat disc, It's a rounded shaped disc. And that's very critical on this particular design because of this seat. This seat here has a very, very small, it's a 5-degree taper with the inside being the highest point. The function of that 5-degree taper is that when this seat closes on that disc, there's a raised portion right there that hits that disc and closes it very easily. If that disc was rounded because it was bulged out, you can see that it would take a lot harder, a lot more force to close that particular mechanism. So the function of these spacer washers is to make sure that I do not over bulge this disc. So, how do I know how many of the spacer washers to use? Well, majority of the time you'll take the one that's in there. If there's one in there, it should come out that way. But you want to make sure. So what you're going to do is take your disc retainer, take the spacer washer, and what I'm going to do, instead of putting it over the hole like this, I'm going to put it like this. And what that's going to allow me to do is put this over the top so I can see if I'm taking up that distance. Get rid of this disc for a second. In other words, as I put these two together, you can see the difference right there. So when I put the disc in, I want to make sure that it's not bulging that disc. So what I'm going to do is place this here, and as you can see, I'm going to cover up the hole, hold it like this. By placing it on top and just placing light finger tension on top, I want to see if I can hold that in place. By pushing down here, you can see this moves very easily. So I'm going to try 2. And when I try 2, you'll see that I push down, suddenly now it doesn't move. So if 2 was enough to stake it up, take that spacing up, I'm going to take 1 away, because that's going to allow me to be able to tighten that enough that it won't bulge it. Because if I put too many in there, in other words, if I put 2 in there, like that, now what's going to happen is it's not going to grab that disc and hold it in the retainer. So sizing the spacer washers is important. Making sure you do that when you rebuild it. Putting it back together. After I've got my spacer washers sized, put the proper amount, 1 or 2. My disc into my disc holder, like that. My diaphragm is going to go next. Diaphragm retainer. And my stem nut. Now, once I get this tight, I want to be very, very careful, making sure I don't scar that stem again. But it's like loosening it was important, so is tightening. This has to be very, very tight. Again, on 6-inch and below, I want to find something that I can put this in, like a soft vise, brass jaw, something like that. 8-inch above, there's a wrench flat that I can reach easily. On the smaller ones, you can kind of reach the wrench flat here, as you can see there. But the important thing is that it has to be tight enough to make a water seal all the way along that diaphragm and that disc, and making sure you do not over bulge the disc right there. So that's our stem assembly. Let's take a look at our body. Now, where this stem assembly sits, in the body like this, you'll notice that the motion of that mechanism as the stem assembly moves up and down, you'll notice that the diaphragm moves up and down. Well, that's obviously important for this area right here where that diaphragm moves. This has to be perfectly smooth. If it's an epoxy coated one like this, usually all you need is a nice rag to come in and wipe off any kind of scale accumulation. There usually won't be any kind of rust issue because the epoxy bond will make it so that it does not rust. So you have to clean the body. And as you can see, the passageways along here can be hard. And if it's epoxy coated, it'll be easier. But if it's not epoxy coated, you've got to make sure you remove any of the dirt or debris. Because any dirt or debris that you leave in there could sit on the seat, causing that disc to not seal properly. So clean the body is important. Again, if it's epoxy coated, it's going to be a little easier. The seat, as I mentioned earlier, can be many different materials. They have it out of stainless, bronze, some other materials that are available. Bottom line is that up to 6-inch, the seat threads in, as you can see here with the O-ring on the back side. 8-inch and above, the seat places in, and there are screws that hold it in place. If you have to remove the seat because it's worn, that you do have to remove it. On, again, the 1/2 through 1 inch, it actually has a hex socket around it that a socket will fit in and unscrew it. On the 1¼ inch through 6, like this one, you'll see these 3 little arms on there. Clavel actually makes a tool that allows you to go in there called an X109 tool, which allows you to unscrew the seat and remove it from the body. If you have to remove the seat, it's sealed by an O-ring on the bottom, as I said, except for the very, very old bodies, going back 30 years or so. Very old style, actually had plain pipe threads, but they went to an O-ring design, thank God. Made it a lot easier for the seat to seal. One of the problems that you're going to look at inside the body, besides rust, if it's if it's not fused epoxy, is the effects of cavitation. And what cavitation is when you start seeing the metal, or sometimes the bronze and stainless, eaten away inside the body. And it'll look like somebody took it on a grinding wheel and just grinded it down. One of the biggest problems people have when they install these pressure regulators is that they oversize the regulator. And one of the problems of oversizing the regulator is that the stem does not travel through its full travel. Believe it or not, this valve is designed to self-clean itself. Every time that stem moves up and down, it wipes itself on the bushing on the top and on the seat below. And as water goes through it, it cleans it. So it's kind of like a self-cleaning assembly when it's used properly. But one of the problems, if it's not used enough, meaning that instead of it stroking like this, it just has very minimal demand and just barely opens like this. The water travels at such a high velocity between that disc and that seat, it actually breaks down the water molecules, creating an issue called cavitation, which will actually start eating that metal. And cavitation is something that will actually destroy those metals in a corrosive environment. So it's very important that you check for any wear or tear inside the body or the seat. And if you see that kind of cavitation issues, you have problems where the valve is undersized and may need a bypass assembly around it for the lower flows. So that's the body. Check our body, make sure it's clean. Seat, making sure it's got our nice little raised part in the middle. There's actually a 5-degree taper, as I say right here. Now for the cover, same issues as the body that we discussed with the materials, meaning is it epoxy coated or not. Again, making sure it's clean. As you can see, the little ribs here and along the body, that's what grips that diaphragm and seals it across the top. As I mentioned, that when this moves up and down, that diaphragm has to flex up and down, and that has to stay sealed here on the body, one, so it doesn't leak, but also to make sure the stem assembly travels. Inside the cover, there is a bushing, and the bushing literally just threads inside the cover and is designed to guide the upper portion of the stem, just like that. So it's guided on the bottom through our seat, and on the top through our stem, so that it's guided through its whole travel. So that's an important part of our cover, that we have to make sure that the bushing is okay. If the bushing has excessive wear or tear, or has been in any way, shape, or form misaligned or scarred, it may have to be replaced. As you can see, it simply threads into the body. The body itself has 4 passageways on the cover, on the small sizes, more on the larger ones. And these passageways correspond to what's on the top. In other words, this is where our sensing line for our pilot-actuated controls come, through here. So we want to make sure that this is fully open. Sometimes, especially on the uncoated bodies, this will be rusted up solid in these passageways. So you want to get in there and make sure you clean them out so that you can have a good passageway through our tubing on the bottom. Very, very important that that's clear so we have full flow of water. We have the corresponding other side of the smooth part of our cover right here, which corresponds with our body where the diaphragm sits. And again, the serrations here that hold that diaphragm into the cover. So now we're ready to reassemble this. Let's go ahead and get it ready to go back together. We've replaced our rubber parts. So at this point, after we've cleaned everything out, we want to go ahead and flush the line, which means with our outlet still shut off and our inlet shut off, we want to now open our inlet water line and kind of let some water flow through and clean out the body, making sure any dirt or debris that's on that first slug of water cleans as we open up the inlet shut-off valve. Once we flush the body out, close our inlet shut-off again, keeping the number 2 shut-off closed, putting our stem assembly back in top on first thing we want to do. Next we want to put our spring. Now on this particular unit, because it's stainless steel, there's nothing under the spring. But for the epoxy coated version, if you had the one that was epoxy coated, there's actually a washer that sits here so that the spring does not damage that epoxy coating. Next thing that's going to go on is our cover. We're going to go ahead and place our cover on top, being very careful that our bushing does not get damaged. There's a plug in the top of the cover, which does allow you to get on top and look inside to make sure you are not damaging that cover and that you go straight up and down over that bushing so it does not damage it. Once you've got the cover on place, our bolt holes should line up. Go ahead and just throw the bolts on hand tight for now. Once we have all the bolts hand tight, we want to make sure we tighten this diaphragm in a controlled fashion. In other words, we don't just want to tighten one side down and then go to the other. You want to get them all hand tight, snug here like a car tire. You snug opposite sides, and then go back and tighten, tighten, tighten. It's very important that we do that crisscross style of tightening so that we don't cock that diaphragm or tighten one side over another. We want to have an even seal across that diaphragm where it attaches, where it's sealed by the body. So that's our high troll body. We've got that rebuilt. Now we want to talk about our pilot control valve. Clay valves happens to be model CRD, which is just the model that they call their reducing pilot control valve. You'll notice that there's always a cap on the top, and some of them actually have a locking cap. The function of that cap is to cover up this bolt and this lock nut. This lock nut should be down tight because that's what actually controls our pressure on the downside. In other words, adjusting this screw is what sets the pressure on the downside of this unit. So there's a tamper cap like this, which has sometimes a little wire through it so it can't be damaged. They actually have one that actually locks on the top so people keep their hands off it. Anyway, this is what's called a CRD. And a CRD is just their pressure control valve, which controls the pressure on the downstream side, which causes the main valve to open and close. So this is kind of the brains, if you will, of that assembly. Main water travels through the main valve, but this little valve on the side is what controls it. Let's go ahead and look at our CRD and take it apart and see what's inside. First, you'll notice that there are 8 screws on the CRD, and it's a 3/8 inch size. So I want to, first thing to do is take my control valve out of the pilot system so I can work on it easily. First thing I want to do is find where that lock nut was. Hopefully this is locked down. That's where it was set before, so theoretically that's where you're going to want to do it. So you want to loosen the lock nut and just back off the screw 1 or 2 threads to take the load. There's a spring in here. I want to take the load off of that for a second. But I don't want to lose my reference point of where it was before, because that's where I want to try to put it back, because that's hopefully where I start when I go to adjust my pressure. Second thing I want to do is, while it's on a bench like this, is get a large size wrench and loosen this nut on the bottom, which will be on there very tightly. But it's easier to loosen it while it's off. Now, once I've got this loose and that loose, I can go ahead and remove my screws. When I'm done with all my screws, the cover will come off, and what will be exposed is a spring. Springs are actually color-coded. There's 4 different spring ranges of the CRD. The function of the CRD, as I said, is to control the downstream pressure at a constant level, regardless of incoming pressure. The standard one, which is what this is, and it'll say on the sticker on the side of the unit, this is CRD 30 to 300. That means we can adjust incoming outlet pressure within that pressure range utilizing this particular control valve. They also have one that regulates between 15 and 75 pounds and 2 to 30 pounds, and a fourth one that regulates between 2 and 6.5 pounds. Again, depending on the applications, there's times you may need different spring loads and different control functions of this pilot control valve, and it's basically done by changing that spring. Once I have the top off, I want to go back on the bottom, remove my plug, and underneath it what you're going to see is your actual seat of this pressure, the disc of this pressure regulator. You'll notice there's a screwdriver slot which allows you to go in and loosen this, which is actually your disc for your regulator. What you see under there is the seat that that disc seals on. Once I've removed that, now I want to grab my diaphragm assembly, and I want to be careful because you'll notice it has this yoke assembly and there's a neck in the middle, so it has to go down and over this neck. So as I go to take it apart, I've got to find out where the yoke is, pull it back, and bring it out in one piece like that. Once I have the yoke and diaphragm out, one nut will be on here. So I hold back on my yoke with a wrench, tighten my nut, loosen my nut I mean. If I loosen my nut, I'll have my diaphragm washer, diaphragm retainer, diaphragm, and yoke assembly. And those are the parts of my CRD that I want to rebuild from my pilot control valve. When you buy the rate pressure factory repair kits for this unit, they basically make two different CRD repair kits. The standard unit, which will have just the diaphragm, the washers, and that disc, is what's usually needed for the CRD. But if you have any of the low-range ones, there's a second kit that has this small little spring in it that you can see right here in the kit. It's called a bucking spring, which actually sits in the center of this disc on that model, where it sits in the very center there. And again, that's used for the lower pressure assemblies. The standard unit does not have a spring. The lower pressure range adjustments one does. So let's put this back together. Take our yoke assembly and our diaphragm, have it ready to go back together. Diaphragm washer, diaphragm retainer, then diaphragm washer. Our nut. We want to make sure this is very tight, so we need two wrenches, one across our yoke and one across our nut. But before we tighten it down, we want to make sure the diaphragm is in the right location. One of the things when you're putting the diaphragms back together is, one, you put it on top to line up the bolt holes. And then once you know it's in the right direction, the second thing you want to do is fold the diaphragm down. The function of this fold down purpose is to make sure the O-rings the diaphragm is in the right place. If you fold it down and the two holes go right over the arms of the yoke like this, it's in the right location. Meaning that now I can tighten my nut down because those two holes are right there, so that when I go to put it inside, the bolt holes will line up with that yoke assembly. So very critical, make sure you get those two holes right there to line up with the arms of the yoke right there. Once I have it in place, two wrenches, tighten that nut very tightly because I have to facilitate a water seal across that diaphragm. For the normal repair, you don't touch that seat on the inside, you just leave it alone. Our yoke assembly will now go inside, and you see where I've got to go over the neck where the seat sits. So I've got to go over that and then slide it over. And if I did everything right, the bolt hole should line up just like that. Now I can go ahead and put my regulator disc into the yoke, and what you'll catch there, right there. This also has to be very tight. Now I can go ahead and put my cover back on, and you'll notice that's the guide for that lower disc. You see how it sits right inside there. So I want to make sure it's right square in the center. So I have it in place. My spring will go on first. The cover will go on next. Now you'll notice on this cover there's a hole drilled right here in the top. And as you can see, underneath here, there is no water pressure. Water comes from the bottom. This is a pressured open regulator, which means when it puts water pressure on, it closes, and all the water stays below the diaphragm. So by having this hole on top, it does two things. One, if there's a leak in the diaphragm, water will come leaking out this hole, and I'll know there's a problem with the diaphragm. But also, as this diaphragm moves up and down, it strokes, and there's a displacement of air. So there has to be a place for that air to go. And so as that diaphragm moves up and down, this becomes a breather hole, which allows the diaphragm to move easily. If I left that without a hole right there, that would be air, and every time that diaphragm came all the way up, it would compress the air inside that cover. Air compresses and water doesn't. We don't want any issues with the pressures changing inside our control valve, which could lead to issues when we go to set our adjustments on it. So we've rebuilt our CRD now. So at this point, we would put our CRD back into our tubing, having it ready to go back together now. So what we've done is rebuilt our hydro valve, rebuilt our pilot valve, our CRD right here. Now we want to test it and see how everything's going to work. So before we go any farther, with the pilot still disconnected, inlet valve still shut off and outlet valve still shut off, I want to turn pressure on slowly. In other words, very small amount of inlet pressure coming on with my cover open. This is the access to my cover. Remember, this is where that tubing goes between the cover and my control valve. But what I want to do is allow water to come in from the top. Now, what I'm going to see is a couple things. I want to see what happens when I first pressurize the inlet side. But before I turn that pressure on the inside, what I want to do is see how that stem's going to move up and down. We have a cutaway, so it's easy to see. Obviously, if this was a whole unit, we wouldn't be able to. What happens is the center of those stems, as I mentioned earlier, has a thread in the inside. There's a female thread so that I can put a bolt on the inside like this. This being a 3-inch, we're dealing with a 1/4-inch fine thread bolt. So by placing a 1/4-inch fine thread bolt in the top, like this, and a washer, you'll notice I can stroke that stem up and down. And why I want to do that is I want to make sure that the stem moves easily. I don't want any grinding or galling action taking place as I move it up and down. If I feel it galling or grinding or it stops at a certain point, I want to be very careful because that means something could be wrong with my bushing up here, or my seat on the bottom, or my stem. Now, so I can put that bolt in there, and you can see they have different size bolts depending on the size. The next thing I want to do before I get this water on is measure my travel. In other words, I want to put this in place here like this, and I'm going to put a marking right here. And then I'm going to go ahead and pull it all the way up and mark it again. And then what I'm going to do is measure the distance between those two marks. If you look on our chart here, the distance that it should travel for a 3-inch regulator, for a 3-inch hydro valve, is 0.8 inches. A little over 3/4 of an inch. So if I come in here and mark a pen like this, pull it all the way up, mark it here, the distance between those two marks should be a little over 3/4 of an inch. If it's less than 3/4 of an inch, it means I have something binding or galling my stem so it can't travel. It won't go farther than that because it's impossible to have that mechanically, but it's usually a shortage that it goes less than what the chart shows you. And if it goes less than what the chart shows you, take it apart again because something's restricting it from its easy travel, as you see right here. Now, back to turning that pressure on slowly. After I've made sure my stem moves slowly, I'm going to notice that there's a certain area of water up here on top of this diaphragm. And that actually has a certain volume. And what's going to happen when I first turn this on is water's going to come underneath, cause that stem assembly, and I'll just use the stem lifter again to show you. As I first go to turn it on, water's going to come underneath, and with this valve wide open on the cover, all it's going to do is open that stem all the way up like this. Because water's pushing underneath, there's no pressure on the control on the cover because this is wide open, opened atmosphere, and water would come out of there if there was anything, and it's going to go to this open position. So I want to make sure that it goes all the way open. Now I want to inspect it. If this was pressurized, this area would have been full of water. And when I did this, all that water would have gushed out through the top of that cover. And the amount of water that would have gushed out of a 3-inch, as you can see here, is 0.080 gallons, which is a little over about 10 ounces. So there's about a coffee cup worth of water on the top of this cover. By having this full of water, when I go to turn that on, that amount of water will come out. But I want to observe it. I want to get so I can put a little meniscus there so I can see that level of water on the cover. Because if I have a leak across my diaphragm with this on and this open to atmosphere, water should come out of this cover. So if I see more water coming out, I know that my diaphragm isn't tight at this point. After I've done my stroke test to make sure it moved, after I've opened it all the way with my displacement to get all the water out of here, make sure there's no leak across my diaphragm, now I want to close my hydro all the way. And what I'm going to do now is go ahead and attach my tubing. And by attaching the tubing to my bypass, I'm going to cause the water to come in, as I say. Now it's going to close this because I'm going to have this shut off still from the water shut off on the downside, and it's going to cause the stem assembly to go to a full closed position. Now, with it in a full closed position and pressure underneath and pressure on top, I can inspect for leakage. In other words, if there's any leaking on the bottom side of here, I can tell across the cover, across my control valves. In other words, before I take it back into the system, I want to make sure I don't have any leaks, and that's how I check. Once it's pressurized and it's closed all the way down, I can make an inspection of there. Now, there's some parts of this valve we want to talk about, and because when we go to turn this back on, it's not just a matter of putting that screw back where it is and hopefully that's where it stands, because we do have to take our adjustments. Because obviously we're building it because there was something wrong, and probably the usual increase in pressure is what generated this repair. But I start at that starting point. And what I do with the inlet pressure on at this point is I have to have water flowing on the downside. In other words, a standard direct acting regulator, I can sit there and tighten this screw down and I can see a gauge go up and down. I want to put two gauges on this particular assembly. I want one on the inlet side and one on the outlet side. It is an option you can get when you buy the regulators, but it's very important when you're setting or trying to adjust this that you have two regulators, one on the inlet and one on the outlet. So what I want to do is turn that water on. And the first thing I want you to see is that in every one of these valves, and it may not be obvious, is a restrictor fitting. In other words, here's a cutaway of that restrictor fitting. You can see on the inside there's a small little plastic piece here. You see the hole right there showing that. The function of that fitting is to allow a certain volume of water to go through the inlet into the cover. This is important because that amount of water makes sure that the cover will cause that relief valve to move in a controlled fashion, not slam close or slam open. It's an orifice in relationship with the size of the CRD to make sure that the water comes on or off the cover in a controlled fashion so the diaphragm assembly moves up and down. But because it's a small fitting that looks just like a standard compression fitting in the control valve, or in the tubing I mean, sometimes people do not realize how important that is. If we do not have that restrictor fitting, you will be flooding the cover, causing this thing to slam closed or slam open, unfortunately. So this is a very, very important part of that valve. It's something that's almost invisible if you don't see it. The second part that you may or may not have, depending on the size and options, is a speed control. The function of this is to control not only the orifice fitting controls it, but this further controls the volume. And by opening and closing this speed control, it allows me to control the speed of how that diaphragm opens. In other words, with an orifice fitting, we're worried about balancing the inlet and the outlet side of our CRD. But with this, because of whatever piping I have downstream, I want to close the relief valve slower or open it slower. I have what are called opening or closing speed controls. And this controls the volume, in this case going onto the cover, causing it to close. So by turning this clockwise, this on the top, kind of like my regulator, this will cause the diaphragm to close even slower after the orifice fitting. So these are two adjustments that hopefully you shouldn't have to touch, but they are there for adjustments. Obviously the orifice fitting is critical. That has to be there. There's no adjustment on that. But if you have an opening, or if you have a closing speed control or an opening speed control, it can affect the movement of that diaphragm. As I said earlier, with our lock nut here, we might have loosened that just to put it back together. We want to start off at that point where we started. Now with my gauges on the inlet and outside, my inlet pressure on, I want to slowly run water on the downside over here. This is my inlet, this is my outlet. So as I run water, I want to watch my gauges. And I want to make my adjustments slowly, no more than quarter turn increments on that screw to make sure I adjust my pressure. So as I'm looking at my pressure gauges, I will be handling my CRD, and it's going to be clockwise to raise pressure, counterclockwise to lower pressure. So if I want to raise my pressure, I just keep going down. That's what I'm trying to do on the downside. So that's our high troll valve. This is our bypass pressure regulator, which controls our main high troll valve, our pilot valve, if you will. There's another thing you saw me putting this screw in here to make sure I can see the stroke on that stem. There is another option that Clayval produces called a position indicator. And a position indicator has a stem that goes in the center of that plug, and instead of there just being a plug on the cover like it usually is, it has this little piece that threads on top. You'll notice it has a little inspection window, and inside that window you can see that stem moving up and down. This is important if you have applications where you want to monitor the movement of your stem, making sure it goes full open or full close, or how fast it goes. You can adjust with your opening or closing speed control depending what your issues are. And it also is used on some applications where they have pump valves where this stem will go up and down and actually trigger a little limit switch on the side. So depending on the functions, some can be just like this where it's just a glass to view it. Some will be where the stem sticks up like this where there's a smaller lowering on the outside and the stem moves up and down, which can also activate different parts inside of a valve. Once it comes out, normally there'll just be a plug. Now, through our regulator, as I say, the main valve, high control, pilot controlled on the outside, inlet here, outlet there. Once we've got our adjustments set on the downside, then we can turn our system on. One of the things I forgot to mention is that once you've pressurized that assembly and stroked your stem up and down, you want to make sure you removed all the air out of this assembly. Removing this cover, you'll have that open with water as it goes up and down, so you'll know you got all the air out at that point. But you also want to get the air out of the control section. So when you had this tubing off, and this was open to atmosphere, obviously that would have gotten the air out, but you want to make sure you loosen the tubings once it's pressurized at all different locations to make sure all air is removed out of that tubing. Remember, air compresses and water doesn't. So I want to make sure I've got all the air out of there. So this is my clay valve model 9001 pressure regulator. It's a pilot actuated pressure regulator where the main valve is controlled by the pilot on the side. And that's how we go about replacing the rubber repair parts and rebuilding it for a normal repair.